Welcome back. We are going to take a look at how to create a box plot using the same data set that we started with for our dot plot. Now, just like with the dot plot, I need to create a number line and I need to have everything evenly spaced. And one thing I forgot to write down in my earlier video was the title of that number line. Shame on me. Mustn't forget the titles for your number lines. Now, in order to come up with my box plot, I actually do need to find my minimum, my first quartile, my median, my third quartile, and my maximum. Now, while I'm at it, I'm also going to find my mean and my standard deviation, because by doing the same feature on the calculator, I can actually find all of those at the same time. Now, what I'm going to do is go into Stat. I'm going to hit Enter on Edit, and I'm going to type in all the numbers that I have at the top here. So 60, hit Enter, 61, hit Enter. Bear with me while I go ahead and type these in. Typing and talking is not my strong suit. And I think I missed a number. Add 70, 68, 67, 66, 2, 3 of the 65s, 2 64s, 2 63s. Oop, I needed 3 62s. All right, now I'm just going to type that in at the end here. It actually doesn't matter if these are in order or not when you're typing them in the calculator. So now I see that my last number was the 19th number. And I know that I had 19 numbers in my list. That's how I'm kind of double checking this. I'm going to go back to Stat, and this time I'm going to calculate. So what I did is I entered my entire single quantitative variable data set into the first list in the calculator. Now I can either calculate with that list or I can do a test with that list. Now, tests are reserved for inference. Right now we're just exploring. So I'm going to go to Calculate, and I want to explore that single variable and all of its statistics. Now, the list part is asking, where did I actually put that data? The frequency list, if instead of actually typing 61 twice, I wanted to write down 61 a single time, and then next to it in the next list, write down the proportion of times it occurred. For example, if something happens 20% of the time, then you would write 0.2 as its frequency. If something happens 15% of the time, you would write 0.15 as the frequency. We did not do that. We just entered all the numbers in exactly as many times as they occurred as responses in the survey. And so I'm just going to use list 1. I'm going to skip the frequency list and go to Calculate. Now, what this just gave me is the top number is my mean. So X bar represents the sample mean. So 64.18 approximately. My next thing would be the sum of all of my values in the data set. So if I were to add up all of these numbers, I should get 1,219.5. If I were to square all of the numbers and then add them up, then I would get 78,430.25. Now, these two numbers are often used for double checking your answers, making sure that everything was entered properly. The next number I'm really interested in is this S sub x. Now, S sub x stands for sample standard deviation, and that number is approximately 2.959. I usually like to take my standard deviation out to about 3 decimal places, 2 at the very least. Now, standard deviation is telling you how far on average all of these data points varied from my mean value. So my students' heights in my second period class varied from the mean of 64.18 inches by an average of 2.595 inches. That's the true meaning of standard deviation. Now, right down here, you're going to see this arrow. And that means that I should be able to use that down arrow and you can see more calculations popping up. So I have my minimum, which is equal to 60. I have my first quartile, which is the middle of the bottom half of the data, which is 62. I have my median, which is 64. My third quartile, which is 66, and my maximum, which is 70. Now before I go in and start actually drawing my box plot, let me go ahead and check to see if I have any outliers. For that, we actually have a formula. Our first quartile minus 1.5 times our interquartile range. And interquartile range stands for the difference between your third quartile and your first quartile. So how wide is that middle 50% of the data? In this case, IQR is 66 minus 62, which is equal to 4. So for my lower bound, for what constitutes a number that is not yet an outlier, it's like my lowest number that has not yet become an outlier. I'm going to take my first quartile, which is 62. I'm going to subtract 1.5 times my interquartile range of 4. Now 1.5 times 4 gives me 6. You have to do multiplication before you do subtraction. Be very careful to actually do this multiplication before you try to subtract from the 62. Once you complete that subtraction, you have 56, and none of my students identified having a height of less than 56, so I don't have any outliers on the low end of this. Now for my third quartile, just realized I was off the screen for some of that. For my third quartile, I need to add 1.5 times my interquartile range. So 66 plus 1.5 times 4, 66 plus 4, or sorry, plus 6, because 1.5 times 4 is 6, and that equals 72. So I don't have any numbers less than 56. I don't have any numbers more than 72. Now, if you have numbers that are exactly 56 or exactly 72, those numbers are not yet outliers. They actually have to be numbers that are more extreme than these values. So smaller than this small number or larger than this larger number. So when I go to create my box plot, let me adjust my camera just a little bit, make sure that you can see this. I'm going to start with my minimum and just make a small tick mark at the 60 above the number line. At my first quartile, I'm going to create a larger tick mark here to start my box. My median goes in the middle of my box, so 64 is right here. So I'm going to make that the same size as this previous one. Then the last part of my box, 66, is going to go right here. Finally, my maximum of 70 can be right over here. If I connect these, I now have my box, and then connect the box to the extremes, and I have my box and whisker plot, or just a box plot. The name was changed a few years ago. Now what I like to do with this to determine if I was correct in my first video that this is really skewed to the right, I like to look at how far the data spans from the median to the minimum and the median to the maximum. Now if you look from 60 to 64, that's a difference of 4 units. If you look from 64 to 70, that's a difference of 6 units. 6 is definitely more stretched out than 4. And if you look at this and just kind of estimate, you can see how much further this is kind of extending beyond that minimum. So this is definitely stretched out to the right, which makes it distorted to the right, so it's skewed to the right. Most of my points are actually right here between 60 to 66, but then this upper 25% is kind of stretching further than the rest of the points. It has a larger spread than the rest of these points, and that's what's causing what we call skewness. So I do confirm that this is skewed right for my shape. Now, the limitation with box plots is that you can't actually see any of your peaks, so you don't know if you're unimodal, bimodal, trimodal. I would probably just call this unimodal because the difference between having 3 of the same number versus 2 of the same number, it's not really that big of a difference. So I would probably just call this maybe unimodal, but I would just refer to it as skewed to the right. I wouldn't even try to identify how many modes it has because it's so close to being uniform. I would just stick with the skewed right. All right, when we come back, I'm going to take a look at how to turn this into a histogram now.